Today, we're going to look at isosceles triangles. So remember, isosceles triangles are triangles where two of the sides are the same and the third one is not. And the main thing we're going to use today is what Savas calls the isosceles triangle theorem, but it's usually called the base angles theorem for a reason that we'll talk about in just a minute. So it's an if-then statement. If two sides of a triangle are congruent, isosceles, then the angles opposite those sides are congruent. So in this case, it says if two of the sides are the same, which they marked as A, B, and B to C, then the angles opposite those sides are congruent. So we go opposite this side, gives me this angle, is congruent to opposite this side would be this angle. So those two angles, basically angle A and angle C, have to be the same. And the reason that it's called that is because this side, this third side that isn't the same, is typically called the base in an isosceles triangle. And the two sides that are different are called, the two sides that are the same are called the legs. So when we talk about the base angles, we're talking about the angles that are sitting at the base. So that is how the statement looks. So I'm going to pause here for about 10 to 15 seconds and let you think about what the converse looks like. I'm about to show it to you. So see if you can remember what the converse is. Here's an if-then statement. Tell me what the converse would say. And hopefully you remember that the converse involves taking the statement and switching it. So the original says if two sides are congruent, then the two angles opposite them are congruent. So the converse will say if the two angles are congruent, then the sides across from them are congruent. So it tells me that the base angles are the same, and we can use that to say that the legs are the same. So it's a way both to find measurements in isosceles triangles or to know that a triangle is isosceles. So it works both ways. Both the statement and the converse are true. So let's look at a couple of problems that use this idea that you're going to see on the Savas assignment we have today. All right. Now, let's start with a fairly straightforward one. We have the measure of angle A is 28 degrees. So this is 28 degrees. There's angle A. And you'll notice that it's isosceles. So here are the two sides that are the same. So therefore, here are the base angles that have to be the same. Now, I don't know what those angles are, so I'm going to call them X because I don't know them. And we are going to use a very common fact that you're going to see in these examples today, which is that the angles in a triangle, we've talked about this before, the angles in a triangle have to add to 180 degrees. That's a very, very handy tool in trying to solve for the angles in a triangle. So I know that the angle A is 28. And I don't know what B and C are, but I do know that they're the same, which is why I'm calling them X and X. They're both X because they're the same measurement. So when I go to solve this, I'll have 28 plus X is 2X equals 180. So then I can go through the process of solving. Subtract, divide, and get my answer. So 2X equals 152. So then I can divide by 2 to get rid of the multiplying, and that will give me X equaling 76. So that means these angles are both 76 degrees, and you can double check, as you always should. We can add 76 and 28, And indeed, they will add to 180. So to finish off and actually answering the question, the measure of angle B should equal the measure of angle C. They should be congruent, and they're both 76. So again, it's a way to use the sides to get the angles, or to use the angles to get the sides. Here, we're using the sides, the fact that the sides are the same, to say, therefore, the angles are the same. Next. Find the perimeter of the triangle. So we'll come back to perimeter, but as always, in these equations that have x in them, let's go ahead and solve for x. Now, you can probably guess that this is isosceles, but let's make sure by figuring out the measure of angle A. So try this on your own. I'll give you about 15 to 20 seconds. See if you can figure out the measure of angle A. Remember what the angles add to. Hey, it's using the fact that the angles add to 180 degrees. So 132 and 24, that's 156. And if I take that away from 180, then I get that the measure of angle A has to be 24. And that's great news. If they're both 24, that means they're congruent. And if they're congruent, that means that the sides across from them are congruent. Here's the equation that we can build. Again, I'm just showing what I mean by across from them. I'm standing at the angle, looking at the side across. Those are my two angles that have to be the same. So I have 2x plus 15, and I have 4x minus 5. And they have to be equal. That's the whole idea. They have to be equal. We're going to make them equal to each other. And now we can solve that equation. So we're going to subtract 2x from both sides. Get everything with x on the same side. And then we'll add and we'll divide. And that will give us x equaling 10. All right, not done with the problem yet, but we have solved for x based on the fact that those legs had to be the same. So let's go ahead and figure out what all the sides are by plugging in 10 for x. A to c and b to c should be the same thing. Let's see. 2 times 10 plus 15. We're plugging in 10 for x. That is 35. Over here, 4 times x is 10 minus 5. That's 40 minus 5 is 35. Hey, they're the same. Oops, 35. They're the same, which is what's supposed to happen. Nothing's saying that the last one has to be the same. Let's see if it is. 4 times 10 plus 12. That's 40 and 12 is 52. Okay, they aren't the same. But that's okay, because all it guarantees is 2 of the sides are the same. Not necessarily the third one is, not necessarily what the sides need to add to, just that those 2 sides, those 2 legs have to both be the same. So to finally answer the question of perimeter, remember to find the perimeter of a shape? Well, we take all the sides and we add them together. So we've got 35 and 35 and 52, and that is 122. There's our perimeter. Perimeter, add up all the sides. So once we solved for x, that's when we plugged it back in, figured out our perimeter. So quite a few steps with that one, but still involving the same core idea that because the angles were congruent, the sides across from them had to be the same. And that's a pattern that we'll see later in the year with triangles, is that the bigger the angle, the longer the side that's across from it. And the smaller the angle, the shorter the side across from it. So when we have two angles the same, then they're related to the sides across from them, and they're going to be the same. Next. All right. Now we're going to discover something here, and it's going to make use of the transitive property. So here we go. We're told that CBD is 130 degrees. So measure of angle CBD, that angle is 130. And our goal, our end goal, is the measure of angle BAD, this angle right here. Always helps to trace that out. And this diagram gets a little bit busy, so what we're going to do is we're going to separate out the diagram. So starting with triangle ABC in red here, I'm going to draw that out separately. And I should know what all of those angles turn out to be, because I know that all three sides are the same. And what's going to happen is that because these two sides are the same, so I'll go ahead and label them so you know what I'm talking about. Because A to C equals A to B, that means that angle C and angle B are the same. Because A to B and B to C are the same, that means, by the same logic, that the angles across from them, which are C and A, are the same. Well, we know that if A is congruent to B and B is congruent to C, then A is congruent to C, and we have lined up all three of our angles being the same. So this idea about isosceles triangles leads to an idea that you might be able to guess about equilateral triangles. If all three sides are the same, then all three angles will be the same. And not only that, but we know what all three of those angles have to be, because all three of the angles have to add to 180. So if all three add to 180 and all three are the same, that leaves 60 apiece. All three of them have to be 60. That's the only way they can add to 180. So this angle right here is 60 degrees. And I'm going to use that to go to my other triangle and work out what those measurements are. Because the whole thing is 130 and this part is 60, that leaves this other part right here, 130 minus 60, to be 70. And then, whenever the diagram's getting too busy, separate it out. We have those two marked congruent. We have this angle is 70. And so we can use the same process that we used before to figure out we have 70 plus x equals 180 degrees. So that leaves 110 left for the angles. So since they have to be the same, that's going to leave x being 55. So I have 55 degrees here and 55 degrees here. Hey, that's our angle that we wanted. Measure of angle BAD equals 55 degrees. So we built our way around the shape using the angles that we knew. We made a new discovery about an equilateral triangle, that if all the sides are the same, all the angles are the same. All right, last one. And this one uses a pretty similar idea where we build our way around and go one at a time. So our end goal is angle U over here. And we are just told about one angle, which is 72 degrees. So I'm going to pause here and see how far you can get in journeying your way around here to figure out what angle U is. start with your triangle, original triangle that you're given information about. Work on that, and then build your way over to this triangle. So what I'm going to do is I'm going to get all the red angles. Then I'm going to see what takes me from the red to the blue. And then I'm going to get all the blue angles. So first off, the red angles. We have, this is x. Hey, these two sides are the same. That means the angles across from them will be the same. And we have x again. So we have 72 and x and x. And once again, we're using the fact that the angles add to 180 degrees. And that will give me that 2x equals 108, which gives me that x equals 54. So each of these angles are 54 degrees. Now we need to figure out how we're going to travel from that red angle to the blue angle. Well, hopefully something that you see is that here's what splits it up, and hopefully you can see that these two angles right here, linear pair, they make a straight line. So because they make a straight line, those two angles have to be supplementary. They have to add to 180. So we have 54 here. That leaves the other angle to be 126 degrees to make the linear pair. So this angle is 126 degrees. And same process, we're looking for what these two angles are. I'll use y because we already used x. And we're going to use the same process. 126 plus y equals 180. Those three angles in the triangle, once again, as always, have to add to 180 degrees. So we can go through that same process and find that y has to be 27. So our two angles are 27 and 27. So the measure of the angle we're looking for is 27 degrees. Again, building our way around the triangles, using the fact of those angles across from the sides having to be the same, and using the fact that the angles in a triangle have to add to 180 degrees. Key facts there. So that's our notes for today. The assignment is on Savas.